Hi and welcome to another demonstration of the Steel Detailer. My name is Michael Crawford. I'm the presenter of this live webinar. Firstly, we're going to cover today the concrete panel modelling processes inside SolidWorks and TSD. If you've never seen concrete panels being modelled or put together in a 3D model environment like SolidWorks with TSD, well, you're in for a real treat because there's a lot of repetitive processes associated to creating concrete panels. So yeah, okay, let's get started. What I've also done is I've muted everyone. The reason for that is there's a few people online. I just want to make sure that there's no clutter or noise in the background to affect the actual presentation. Okay, so I guess we'll get started. Firstly, I've already started a project in TSD and I've dropped a couple of items in there. I'm going to log into that through the Start interface, and as you can see, I've already started a couple of models. One of them is the frame sketch, which you can pretty much model up as a dummy driving sketch. It's all standard SolidWorks functionality. I've just created a base sketch, which is the building perimeters, and then I've put in a grid. And I've set my footing plane down for my panels because panels sit lower than the slab, and I've created a sketch which allows me to insert my concrete panels on. Now, I've created this sketch in a certain manner. My panels are going from left to right around anti-clockwise, so if we were to start at the bottom left hand corner here, the direction of the panels as we put them in will go in this direction as I move along, and it will go around and insert them one by one. However, you can set this up any way you like. I prefer to use this standard because at least I've got some consistency. Let's just say you don't have a concrete panel going in, you can take out one of these sketch lines and you know, completely avoid that bay. But at the end of the day, I've drawn this line right round in segments to allow me to put my concrete panels on in my driving sketch. Now, also inside my model, I've created a slab, which is simply just a concrete sort of extrusion and a footing around the base, and this will allow us to create dowel plans down the track for the dowels that have to go in. Now, predominantly I'm going to talk about tilt panels, and the actual tilt panels themselves are a bit different to the panel clad panels because there's two particular types. There's panel clad panels which you can actually cast and make inside a building, avoiding things like weather affecting you know, the progress of your project, or you can do tilt panels which are actually cast on site and they're face lifted and then edge lifted into position and sit on dowels. The panel clad panels actually clip to steel sections, columns and such, to hold them in place. And they use friction plates to clamp them to the columns. So they're a bit different in the design between the two different types. But today I'm just going to cover tilt panels because the tilt panels are used a fair bit in this industry, in the building industry, and they are very common. Now, what I'm going to do first up is I'm just going to drop in a model that I've already created, and you can go and create any model you like. And this model, I'm just going to ensure that you get a very good understanding of what I've done so that you can use it or create your own. So in TSD members, if I go in and go to concrete panels, I've got panel clad panels, which are just stock standard library components that come with TSD if you're a customer. Then there's tilt panel, which I've just created off to the side. Now, I've created this tilt panel from the panel clad panels. What I want to do is I want to put this panel in, so I'm just going to click the image there because that's the panel I want. And what I want to do is just put it on a single sketch segment because I'm going to show you this first and then we're going to show you how panels get inserted. So a single sketch segment is what I want to select, so I just select the single sketch segment and hit my tick, and that puts in a concrete panel. Okay, at the moment it doesn't look like much, it just looks like a concrete panel. Now let's open it up. So I've just clicked on the panel, I'm going into the actual model now. Now I'm just going to go through what's in this model so you can see how it's been designed. Okay, first of all, with all TSD models we have a member sketch to which attaches to our driving sketch, which we selected the sketch segment for a couple of seconds ago. Then inside that we've got our height sketch, which determines the height of our concrete panel. Then we have the panel driving sketch, which is a sketch that allows us to be able to move the panel in and out from the driving sketch. Say for instance, between each panel we have expansion grout to allow the panel to grow based on heat, cold and heat, expansion sort of weather. So I've created a panel driving sketch that allows me to shift the ends in so that say for instance it ends up forming a corner, so I can come in and put a distance on it, so it will decrease the actual panel size. I also have a cover sketch which actually is driven. I'll show you that a little bit later about when we go down to creating the ferrules. The 40mm that you see there is just a cover sketch which drives the cover around the actual panel. Now I'll get into the components, but I'm just going through the sketches. Then what we've got is we've got a grout pocket sketch, and you can change that to suit the scenario. I've put 3 pockets in. You can put as many pockets as you like depending on the design, obviously based on the width of your panel. I also have a starter bar sketch which I attach my starter bars to, which are just simple parts inserted from the TSD library under the parts library. Then I have a mesh panel mesh cutting sketch, which is linked to the cover sketch, so that if I change the cover, this sketch will change. Now what it does is it cuts back the reinforcement part that's inside this, because there is reinforcement in this panel. Now there's also a prop ferrule sketch, so because with tilt panels, when they put them in place, to actually hold them up vertically, prop ferrules, props are actually used, and the actual props themselves are attached to the panel at ferrule locations. I've drawn a sketch there. Usually, rule of thumb, they're about 2/3 of the way up the concrete panel, so you can essentially just do a quick design. I'll set it up so that there's an equation set up for that, so that it's roughly around 2/3 up the panel from the base or from the support, because you may end up setting your panel down 400mm. You might want to just calculate from the base, not from the base, but the top of the slab, because that's where it's going to be fixed. Okay, so now after that we've got our concrete starter bars. Okay, now depending on your design, you may end up having starter bars that tie in to the existing slab or to the slab to which it's going to attach to, and it will be fixed to the reinforcement in that slab. So that's what that sketch is for, and if I rotate around you can see I've got starter bars already preset. Now I haven't set up a pattern in here. You can, with your own modeling, put a pattern in there that has an equation, and you can equally space them or set them up so that they've got maximum centers through your equation settings. Now I've also been a little smart about how I've done this, is that I've got the feature inside the panel, and I've created a derived feature pattern which is right down the bottom here based on the starter bars. So the actual ferrules inside the panel determine where and the quantity of the starter bars, which is a neat little feature in SolidWorks. Also too, in underneath you can see I've got my grout pockets. My grout pockets sit inside. I'll show you what those are in a second. Okay, so let's just go through what parts are inside this so that you can get a very good idea of it. So the actual panel itself is made up of a weldment feature. You might go, well, why a weldment feature? If you're a SolidWorks user, you could use an extrude. I've used a weldment feature because of TSD properties. A weldment feature, we've actually got the weldments. If I was to open up that part itself, you can see I've got the weldment, and there's a member sketch that drives it. I've got some cuts and trims that are associated to the sketches above. But if I go into my weldments tab and have a look at the sections I've got in here, I can go down and we've got concrete and concrete panels, and then we've got thicknesses. So we can actually change the thickness of the concrete panel because it's a weldment. Rather than using an extrude and double click on it, we can just select it and it'll change the thickness. Now how does that work? Well, we've made this panel really large. Okay, it's massive. So we've just used cuts to trim it back. We've put it into a size that no one would actually build as far as the size of the panel goes. That's something like 40 meters high. If that ever happens, you just go in there and you change the sketch to which that's attached to and increase it higher. I've never seen a 40-meter panel, but you just never know. We're breaking world records on all sorts of designs lately. Alright, so that just sets you up for your concrete panel, and if I need to change the section size, it's just a simple edit feature, and I can go straight into the weldment, and you can see the sizes and everything occur in my size list. At the moment I'm just going to leave that at 200, simply because I'm working with this at the moment. So that's the actual panel. Now, in underneath the panel we've got a mesh. If I make this transparent, you can actually see the mesh. Alright, the mesh itself has been cut back based on my my cover sketch, which was that one there, that 40mm, and it's a combination of that 40mm and the panel mesh cutting sketch, which has the perimeters based or clearances based around the outside edge to conform to that 40mm. So if I change that 40mm sketch above here, this outer cutting sketch will increase its clearance to whatever, or decrease to whatever you select. So that's been linked. Not only has that been linked, it's also set that up. Now that's the mesh. If we go down and we have a look at the grout pockets, these are vendor items, by the way. Mesh is a vendor item because we order it in sheets, and the grout pockets are vendor items because we order them from a supplier. Now you'll see the grout pocket. It's nothing special. I've just created 2 cylinders as cuts, and I've put them in to actually show that there is a grout pocket. It might not be 100% exact, but I've allocated a space for it so that I can count grout pockets. There's information inside that part that is useful, so it's not only just a model, it's also a container of information and a counter. Alright, I've got 3 grout pockets in this, and all I've simply done is in my sketch I've got a line that runs across the top here, and inside that line I've got positions at ends and one in the center. You can add as many as you like. You can even pattern them. It's just simple model, SolidWorks modeling. All right. So in the dowels, we've got different dowels. In this case, we've got 3 of them in this model. They're standard M20 dowels. You can set them up at any size you want. You can put configurations inside them and use them at will. Then we've got our starter bars, which are these ones over the back. Usually they've got a threaded end, and they screw into the ferrule inside the panel, and the bar will tie into the top mesh of your concrete slab on the internal side. Alright, so that sets up that. So we can change that at will. Now we've got some other little interesting things in here as well that are sitting inside our model, which have come from the panel clads. There are face dressing fillets, so if I want to run a fillet across the panel, I can simply just go into here and unsuppress one. Now the fillets themselves, there's a whole different type, and we've given you 5 in a row, which means that 5 of them can come in. We've got both horizontal and vertical, so it means that if you want to draw some nice little set downs inside your panel, you can. They're just simple V's. You can create any shape you like and any cut. Now you also should note that with these, we've actually got an extrusion that if there's a horizontal, the extrusion cannot go all the way across the face. The reason for that is because we have names on our faces, so that when we actually cut the face, we need to keep the face consistent on the panel. So I'll just turn off the transparency, and if I go in and right mouse click under the face feature, which is face properties, if you click on that, we've actually got a name for the panel. So this is the front face of the panel, and we only do it for the front, and we only do it for the back as well, so that the panel itself is nominated for ferrule placement when we do what we call a panel lock. So those particular faces are very important. So when you cut your panel or you do a groove in it, what we do is we just extrude right up to the very edge, and we might make the edge an offset so that the extrusion offsets from the edge, say 0.01, so it's really small. And what happens by doing that is that you'll maintain a consistent single face. Okay, so there is a little bit of a modelling tip there when it comes to doing your panels. Alright, now edge lifts. Obviously if you want to put some edge lifts in the top, you've got lifting anchors. Now all we've done is just put symbols in, so the symbols themselves are just a dimension. Now when you lock a panel in TSD, it automatically calculates the centroid, and you can determine what your spreader bar distances are for your edge lifts. For those that don't know what a spreader bar is, what it does is allows you to do an equidistance lift based on the centroid of the panel, and a bar which has some hooks or eyelets and some chains down to the panel that tie into the actual top of the panel itself, trying to maintain some sort of a vertical sort of arrangement from the spreader bar down to the panel, ensures that you get a very good sort of distributed load lift. And that's pretty much what a spreader bar does. And on top of the spreader bar, there's usually a chain or some sort, or even just a hook for a crane to attach to. Alright, so we've created an edge lifts are there for us to use. We're not using them in this case. I'm not going to demonstrate them. Also too, we've got a window 1 here. Now we can add a window to this and create a configuration. It's up to you on how you want to do this. If I click on the window config, it brings in a door. So I've actually got a door. And I've been a little bit smart about this too, because what this means is that when I change my config, there's also an awning sketch that I've set up. If I double click on it, I've got distances there to allow me to insert an awning using TSD functionality. I'll show you that a little bit later. So basically that allows me to drive the awning in its length and its position inside the project attached to the concrete panel. Alright, now I've been modelling inside an assembly here, and I've been carrying through cuts into the part and propagating the features. So if I go back to the window and have a look at the window, the actual component here in this case hasn't been propagated, and it should have. So that is bad modelling, because what happens is when we want to select a face or something like that, to determine what face we're on or that sort of thing, it can have an impact. And in this instance, because it's not propagated to the part, when I go to open up the part, you don't see the window. So if I open the part up, there's no window. The drawings themselves actually do come from the top level assembly, but I do prefer to propagate my models in through to the parts. That means I'm doing an assembly cut. That is an assembly cut. Sorry, that one there is an assembly cut. Now also too, with the window, I've also got a mesh cut in there, so that that mesh cut allows us for our cover. And what that means is that it's driven also by the edge. So when I change the transparency, you'll notice that there is a cover for the Rio around the outside that matches our cover sketch. So if we were to change the cover sketch, the Rio would change. That cover sketch is also used for the outside of perimeter, and it's also used for the mesh cut sketch, which is that one. And you can see that there is a sketch that cuts the mesh. Now this can be a window or it can be a door. It's up to you on how you wish to set this up. I've created a window which can become a door, primarily because I've got dimensions in there that allow me to shift it. What that means is that the bottom dimension is 0. Okay. Now I could make that 350 so that I've got a bottom edge inside my panel. It's up to you on how you do your concrete panel design, but remember that if your concrete panel isn't thick enough, you start inducing cracks and things like that. So it can be a bit messy. I've seen different situations where customers have cast in SHS either end to stiffen the whole thing, and then when they put the panel in, they cut the SHS off and then put the concrete in. It's just one of those things. Different design for different companies and different engineers. All right, so that's that as far as windows go. Now I could add another window in there at the top, so that this concrete panel itself is might have a mezzanine through the middle of it, and there might be another floor in the building, so we've got ourselves an office window inside that. And we can add another config so that we go 2 windows, or we go top window and no window. which is no cuts. So I've just taken the no cuts functionality here, and now you can see what actually is involved in creating this panel. There is also a template, so if we right mouse click off to the screen and click open drawing, there is a template associated to the panel that's been inserted. Now this is a template, it hasn't been finished or finalized. You can see I've got my starter bars called up, I've got my dowel tubes called up, also have my ferrules across the back for the props called up, and there's no symbols on this drawing at this stage because we have not locked the panel. There's also some data that comes in when we lock that changes with the panel size. In this instance, they are just defaults that have been used on something that's been locked before, so the information is still in there. This information links back to the assembly, and I'm going to show you where that is. And this information that comes in here is either automatically calculated or it comes in with some selections of the locking process. So we've got our different symbols. We have our different ferrule information, and this is just a basic template that I've set up for the concrete panel. It's up to you as well. I put a diagonal in for a dimension just to square it off to ensure that you're getting the result that you're looking for when they fabricate it. As formwork, if you don't square it off, it can sort of shift a little bit and throw things out. Alright, so I've got my drawing sheet there. I'm just going to close that off. That drawing sheet is linked to the custom properties, so if I go into my file, properties of my assembly, custom tab, you'll notice there's some information in here. This information is half sort of generated from TSD. Some of it is automatically calculated, like the weight, and that is pretty much sort of stock standard with SolidWorks. The other information, obviously, far face, near face, side ferrules, quantities of panels, the mesh size, the cover, all that sort of stuff is related to a locking process, which I'm about to show you after I do an insert. Okay, so that's enough of me waffling on. Let's use TSD to create a project for us. So I'm just going to close that off. Yeah, you can save it. I'm going to remove that concrete panel. To do that, I go to TSD members, delete member, and then hit my tick. The reason for that is because I'm going to use a different insertion process. Now that panel's been added. What I want to do is I just want to reset my counter. So if I just close the assembly and then open it back up again, it means that when I go to insert my panels, it's going to start off with the first instance for everything. If I hadn't done that, I would have a second instance. It's not a big deal. You can still do it, but I prefer, just from scratch so I know where I'm at. So let's go back up to the TSD members and insert some concrete panels. So if we go into the concrete panel and we go over to our tilt, we click the tilt and we click sketch and click the sketch around the base, we can sit back now and watch TSD insert all the concrete panels for this project. Now the heights of the concrete panels are just defaults. We can simply change all those. I'll show you that in a second once we've inserted the panels. And if anybody's ever done concrete panels before and laid them out in AutoCAD, and you can sort of understand that right now this is probably the fastest way of putting concrete panels in that you have possibly ever seen. Interesting that did that there. There we go, just a graphics thing. It hadn't updated. So it now is just simply putting them in and attaching them to the driving sketches associated to the bays of my my project. Three more to go. Now these concrete panels are all going in as individual concrete panels. As you know, that when you do steel detailing and concrete panel detailing, in some instances you might think you've got the same panel, and then all of a sudden someone comes along and changes it, you end up with a different panel. You can, however, duplicate your panels if you have the same panel. I'd probably recommend doing that at the end because then you can see it. You can go, okay, that panel's exactly the same as that. So you remove one panel from the system and then just duplicate it. Okay, so we've put our concrete panels in, and what you've now noticed is the panels themselves have come in overlapped. That's not a big problem because we can simply just click on the panel and we have a panel driving sketch which gives us our 10mm clearance. In this instance, I'm going to carry this panel through to the edge. Remove that by clicking on the dimension and clicking 0. Now I've just hit Control Q for a rebuild. So it means that that panel now is going to be hard up. Now I've got to do another rebuild. Okay. And now this panel here, I know what the thicknesses of these panels are. If I just simply click the edge of it, it's telling me that it's 200. So I'm just simply going to change the panel driving sketch on this one. So if I double click on the panel driving sketch and click on the 10, I want to make it 220 because with tilt panels, stock standard default is 20mm gap for expansion. So you'll notice now that's changed. And if I look down there, you'll notice the Rio is still sticking out. So I've just done one rebuild, so the next thing I need to do is another rebuild on a Control Q. And that'll give a bit more of a deeper level rebuild. And now you can see that the reinforcement's gone. Now I could do that on all the corners. I just wanted to demonstrate that it's pretty quick to actually set that up. Now, what we want to do in this instance, I'm just going to show you that we can change the heights of the concrete panels in one go. I've got a new feature in TSD that allows us to use match dimensions. So this panel here, if I make it the original panel for the matching of the dimensions, what I want to first do is just go in and just grab the height sketch, and if I wanted to make it say let's just go 8 meters, and we have quite a high sort of parapet arrangement happening on that panel. So now I'm just doing a second rebuild. Okay. So now I'm just saving, just Control Q and then Control S. So now we've got ourselves a driving panel. Okay. Now if we go into the TSD utilities, this is something that you will not have just yet. We are beta testing it, and I'm going to just show it to you. This functionality allows you to make changes relatively quick. What it does is it allows you to, say for instance, all your base plates in your project, an engineer comes back and says that you've put in 12mm, we need 20. Okay, instead of going through each base plate and double clicking on each base plate and making the thickness change, this will allow you to pick the first one after you've changed it and then pick all the consequent plates and then have them automatically update. It's pretty powerful, so I'm just going to run you through that. So match dimensions, we're going to use the parent Weldman Assemblies driving sketches. So it means that if I click on that item, it's going to get the assembly. If I untick that, it'll get the part. Okay, so what we want to do is select the assembly. Okay, and we want to change the panels, or select the panels that are going to change. So we select these panels. Okay, we want the height to change. So if we want to change the dimensions on these, we click the height sketch, and in comes the height sketch dimension. So we click on that, and you'll see that it's been highlighted in the window in your picture, sorry, in your 3D model view. And then what we want to do is we just want to add that dimension because we want to add it so that the changes replicate through the other panels. Once we've done that, we hit the tick, and now you can sit back and watch your panel heights all change automatically. Without having to go through and change the heights on all of them, this automatically changes them for you. So now that's done. Okay. Alright, now we're at the front of the building, which means that over the far edge of our building, what we want to do is we want to change them so that the config on all of those panels themselves replicate windows. So hey, let's just put some windows in on those panels. So the first panel we need to grab is that one there. So if we highlight that, and we know if we count to 13, we've got the rear panels. What I'm going to do is simply just change the config. So if I go over and go to Window and click OK, that'll change all those panels to the windows. Okay, and now we just do a Control Q twice and then an S just to save it so that all the rebuilds have occurred. So now with our window, we've actually got windows in all those panels, and each window themselves are a certain height. But what we want to do is we want to change all the windows in one go. And I'm just going to exaggerate this process so that you can see that with TSD it's quite an easy process to change all the windows in one go to maintain some consistency. Because all these panels have come from the same template out of our model, out of our library, all the dimensions have got similar names. So we can select this one here, and we're just going to make it the member that the others are going to match. So if we go into the window, which is down the bottom here, and double click on the window, we have the dimensions associated to it. So as I said, I'm just going to just exaggerate some of this. So I'm going in and changing the 1200 edge clearance to 800, and then I'm just going to make this a roller door or something, you know, so that it's got some fair height in it. Rather than just being a shop front window, we can now make it into a roller door opening as such. So I've just opened that up. Now obviously the sides and the distance of our roller door, or the edge of our roller door here, would be designed to suit. At the moment that's probably not a very good panel to design. You probably want to create a different panel arrangement for that sort of thing. However, I have seen them. That sort of height and that sort of creation of panels would induce some sort of cracking around the corners, but for all intensive purposes I'm just showing you how you can model. I'm not getting into the engineering design. Okay, so now that I've created that concrete panel, I'm just going to hit Control Q twice and then S just to let SolidWorks update itself to match. Now when I want to change this, I go over to the TSD utilities again and grab the match dimensions. We want to grab the panel that we're associated to, grab the other panels. Now this might be crazy, but to put so many roller doors in, but essentially I just want to show you that you can do this quite easily. In our panel driving sketch area, if we look for the actual window sketch that we've got, there it is. You click on that. What we want to do is change all the dimensions that are associated to that. So if we grab the dimension by selecting our left mouse key and holding it down, and then we add, so that all those dimensions are added to the change, we hit the tick and we have an automatic update of all the windows happening for us so that they all match. Alright, and yeah, that's not supposed to happen, but it has. Not a good thing. That's why I do a Control Q and a Control Save. And this sort of stuff only happens when you're demonstrating, so I apologise. That's not TSD, that's memory and SolidWorks, I reckon. No, I'm not sure what causes that. It will react differently on different computers. So we'll just bring the project back in again, load it back in, and get going again. Our startup menu is coming. Just accessing the internet now. There we go, and we just log in. Go back into the model, and we'll go through that process again and ensure that we're right with everything. So if you didn't see it the first time, you're going to get to see it again. Alright, so back into the utilities, and as I said, this is a in beta. Click the panel we're assessing, that we're matching, click the panels that we're going to change, scroll down to the window sketch, there it is there, click on all the dimensions, click add and hit the tick. Alright, so that should update, there we go. So that selects all those panels in one go. Now, you're in for a real treat here, because what we did was we in the process of creating the panel, we put in an awning sketch. So I'm just going to go into my members and I'll just pick any one of these, and I'm going to pick awning and then TSD. We have an awning here, and I'm just going to put it on a sketch segment. So I pick the sketch segment that's in the concrete panel. So now if I change that door or that opening, this awning will automatically update because its position of where it is all tied into it. Okay, so I've got a basic awning, and with that awning, as it's come in, we've got some sort of whoops, we'll go back. We've got backing, so we're able to go from put some sheeting down into a box gutter and form a box gutter here, so that we're picking up the rain, and also too we've got our bolts for our location into the panel, as you can see. Now we haven't got any ferrules inside the panel, so let's do that. This has been set up as bolt holes setup. That means that there's a diameter 18 hole there, and these are M16 bolts. So for us to put a ferrule inside that panel, we can use TSD functionality. So I'm just clicking out off to the side here before we get started. If you go into the TSD utilities and we go to the insert panel ferrule, right, we click the face to which the plate occurs, and then on the far side we just pick the the ply, which is the thickness of the panel, including the plate. We have a ferrule depth here that we can manipulate that will allow us to change the depth of the hole. 75 is what I've used. You can use whatever size you want as long as it doesn't stick out the other side, because it'll cause an error, and you want to make it thinner. Alright, so now if I hit my tick, that'll put in some holes into your panel for your ferrules, and we'll do the same thing on the other side so that we've got that in there as well. So now we've got the awning with ferrules inside it. Now you don't need to put the threaded insert or ferrule inside the panel. All you need to do is just create a hole, because what happens when we do a panel lock, I've got to do a rebuild there, by the way. I'll bring the window back in. When you do a panel lock, it automatically calculates how many inserts there are, so that you don't need to do this. Okay. Now, just to show you, those holes are there. If I right mouse click and go isolate, there's my holes. Right. Now the holes are set up so that you're aware of it. They're diameter 30s. Okay. Now, if I go into how panels work with TSD, I go into the folder to which TSD is contained, and inside there we have a panels folder. Okay, now this is called a symbols list, and in the symbols list we have our stock standard symbols. Now for a 30 diameter hole on the rear face, we count an M16 far face ferrule, and this gets added to the drawing sheet when we do a lock. You'll notice that for 30s we've used M16s, for 40 holes we've used M20s, for 50s we've used prop ferrules, and 35s we've got a bit of a dowel tube, and a 55 we've got a side dowel tube going on there as well. Alright, and you also notice that for all ferrules that are M20 we've got a side, and for all ferrules that are 30 we've got M16s for sides. So we can pick up all the ferrules all the way around the panel. Alright, in that we have parts that represent those things. You might find this quite odd, but the parts themselves come in when we do a lock. Okay, so we've got far face, side face, near face, and you'll notice they've got some odd sort of concentric sort of stuff. When you put these ferrules in, you've got to have all these lines in there so that when you print it out, it actually looks like it's a solid sort of face. It doesn't render it unless you do that. Alright, so I just wanted to show you that that's where the symbols are kept, inside the panels area, and the diameters are important because you want to make sure that they work and function the way you need them. So these holes are diameter 30s. It means that I'm going to put a ferrule on here when I lock this as a symbol for the drawing for an M16 bolt. Okay. So now if I exit the isolation process, I've got my awning there. Now what I want to do is I simply just want to add the awning to the other windows. So we're maintaining consistency. So if we go back to, say, our awnings, and we continue on and adding the rest of the awnings, so we just click the awning, click the driving sketch, and insert a new awning. Now you simply could duplicate the same awning again. The reason I haven't done that is because what I want to do is just, if I make a change to a panel, the awning is going to want to update. That didn't go in for some reason. I'll just do a Control Q and an S, and we'll have another go. Sometimes you have to do a rebuild to get things to work. Just to let SolidWorks know we're about to insert something else into the model. There we go, that one's going in. Okay, and then we'll add the next one. Oh, and by the way, that awning is completely detailed up. If I hadn't showed it, I think I did show it. I'm not sure. So I'm just adding in the awnings. Alright, one by one. Select the last one. Now on the last panel, I'm just going to show you something there that can happen. Really, it's up to you and how you want to do this. Let's just say we want to put a PA door in this panel, okay? So we could go into the panel itself, and you'll notice some changes happen instantaneously. If we go into the panel itself and we go down to the window, we can adjust this window. There's a sketch in there, okay? Now what I want to do is I just want to pull that dimension off, and I've just right mouse clicked and dragged up, which allows me to select dimensions. I'm just going to put a 900 wide PA door in there. Now our slab is going to be 400 up, and if we go 2160, which is the standard opening for a PA door, I'm going to come up 400 to form the base for the door, because we can RIO around that. I've now created my door, and you'll notice the awning sketch has automatically updated for the door. So I'm just going to save that, go over to the drawing, over to the model, and you'll notice the awning has automatically updated to suit the door without me having to go in and change it. That sort of saves a bit of time and money. Also too, because the drawing is associated in TSD, it means that the actual panel door has moved. We can just go in and just do some tidy up work on the dimensioning inside it, so that we can position the door where it is. And now we've got a door that's cut in. How's that? Is that pretty handy? By the way, that should be set down probably 650 mil from the slab, so that it's not level with the slab, just so that you can fit your door frame in. So I'm just going to go back into the window and double click on it and drop this down 50 mil, so it becomes, say, 350. So make it 350. Now, if there's some ferrules in the road there, you can suppress them. There is, so you can simply just suppress those and hide the features and skip them. It's up to you. At the moment, I'm just going to leave that as it is, because we can come back and fix that up later. My demonstration for this is pretty much straightforward. Now, what I want to do, I'm just going to show you, because I changed that. It means that if I use the dimension program again to effectively change the panels in their window openings, they will automatically update. Okay, so go back over to the window on that one. That's the far one. I need this one. Go back to the window, double click on the window. Let's just go back to, say, a shop front window. Okay, make that 1200. Go back to where we were. Make that 1200. So we're changing effectively one window. Update that window, and you'll notice the awning itself automatically moves. Just saves a bit of time and money. Alright, so now let's just do the same thing again. So if we go to the TSD match dimensions, so we pick on the panel we want to modify, want to match to, then the panels we're going to modify. Select the window again. There it is. Select all the dimensions, click add, hit my tick. And you'll notice that because all the windows are changing, the positions of all the awnings automatically update as well. Is that saving money? Is that saving time? I really think it does. Now, I've only punched holes in this panel here, so I'm only just going to go through the process of locking. Okay, now if we have a look at this awning, I just want to show you that the awning is fully detailed. Right, there it is, got all the details associated to it, all the mark numbers, dimensioning and everything. That awning's ready to go. Might just tidy up a couple of the dimensions through the adjustment process, which you can see here. There's some dimensions here that might need to be modified, and just save that. Okay, let's lock this panel. Now, locking a panel is similar to locking a steel section. What it means is it just puts the drawing into a final state. Now, I'm not sure if you're going to see this happen, but I'll give you a description of it. If you go to TSD members and go lock panel, we pick the panel we want. Now, if there are connections in, it'll pick up the connections, but there are no connections. Now, we can set up the concrete strength, which comes into the drawing. We can change the mesh. Now, an SL82 is the default. We can change it to an SL81. The reason I'm going to show you this is because it changes the reinforcement for you. Obviously, trimmer bars, you can put trimmer bars in around your windows if you like and call them up. It's up to you on how you want to model. Okay, now spreader bar centers, you can set that up, and then obviously minimum concrete cover, which links to the sketch to allow you to change the cover. Alright, so if we hit the tick on that panel, this is the locking process. So it opens up the panel, checks for vendor items, and saves them in the vendor folder so that it'll total them. Now, the white screen is because I'm using a lot of resources at the moment. I'm sorry that you're not seeing what's actually going on. As soon as it finishes, I'll show you what's happened. Resources being that I'm recording the screen, and I've got GoToMeeting happening as well as the 3D model happening. Alright, so this is inserting all the ferrule symbols. It's also adding the data to the custom properties so that it comes out in the drawing, and it also is What else is it doing? It's modifying the quantities and the totals in the description. What else is it doing? Yeah, it's adding all the vendor items and putting the vendor items into a folder so that we can total them. It's updating the database so that we've actually got a quantity. And now you'll see with the drawing, we didn't go in and dimension the holes for the awning too. We probably should have. Okay. So now if I open up that panel, you'll notice now I've got all my ferrule symbols in there. Automatically pick the size to match based on that little table I showed you before. These D's right through to 15 are your ferrule symbols. Okay. And it's also created points. These are snap points, so that if you move anything after you've done the panel lock, the snap points remain. So let's have a look. So there's the symbols for the M16 ferrules. Okay, they're just parts in place, fixed. Okay, around the other side, if we have a look, we've got our M16 ferrules for our far side face, which is a different symbol. Okay, and we also have our prop ferrules, which is a different symbol, which matches. Okay, so we've got our prop ferrules in place. So now we've also got our dowels. Okay, there's no symbols for the dowels because they're just simple parts. Alright, so that's our panel. Now if we go in and have a look at the custom properties, the information for the custom properties has been populated. Quantities, you'll notice the SL81 mesh and the different ferrule counts for the actual panel. Now if I open the model up, the drawing, sorry, you'll see in the drawing we actually have ferrule symbols come through so that you can actually see that they're there. You can notice the different symbols for the M16s there, and they're different symbols for the M16s there for that panel. Now if I had edge lifts, I would do a little bit of a view off the side and show the panel sorry, not edge lift, do a little view off the side for a ferrule that's off the side and create a side view. I've got no edge lifts in there, I've not turned them on, but you can use them. And you'll notice the data has come in. I've got 8 M16 near face ferrules, which is the ones for the awnings. I've got 4 far face ferrules M16s for the starter bars that are tying into the slab, and I've also got 3 far face M20 prop ferrules in there. You'll also notice the data that's come in. Looks like my template's missing the panel thickness, which is part of a setup in there. I'll have to fix that template. The strength, obviously, because we've selected that strength, the volume comes out. The mesh type that we selected, the mass, the cover, and the trimmers that are used in the actual in the model. Now you can set that up so that it's just a note rather than using the table, and on the note you can put your symbols in. It's up to you on how you want to present your templates for your library. Okay, so I'm just going to save that. Now the panel itself has gone through a pretty big stage of putting in the ferrules, which is really handy, and that pretty much finishes off the demonstration for today. I'd like to thank your time for watching this, and yeah, it's been a pleasure to demonstrate it because I always love this part of TSD because you can put together projects fairly quickly. Oh, one more thing I forgot, just to show you so that you can see it. It automatically changed the Rio size based on my selection. I forgot about mentioning that. Yes, okay, so if you've got any questions or you want more information about what I've just done, yeah, please send us an email at support@thesteeldetailer. I certainly want to thank your time, and if you're going into work this morning, enjoy your day, and we'll see you next week. We also have another webinar tonight. If there's something you miss, you can always jump back onto that webinar. All right, thanks very much for your time, and we'll see you again soon.